Let's begin with sampling, data reduction, and with sampling. So, as we have discussed earlier, data reduction techniques are used to reduce the complexity or size of data, making it more manageable for analysis. So, out of that, the best technique that we use, for data reduction is the sampling. That's the first technique we're going to see. So now let's understand what is sampling first. Sampling involves selecting a smaller subset of data from the original data set. So this subset called a sample represents a similar portion of the overall data but retains key characteristics of the original data. Sampling can be done in different ways, including random sampling, stratified sampling, and systematic sampling. So now let's look into the random sampling first. In random sampling, a random subset of data points is selected from the original data set. You can see on the screen, this is your original data set, this is your population, and from this a random data points, a random subset of data points is selected from the original data set without any specific criteria or pattern. So this can be useful when the data set is large and representative of the overall population. And the goal is to reduce the data size while retaining the general characteristics of the data. So what will we do? Let's do a small example for the random sampling. Okay, so a simple example. So import pandas as pd. Let me create a data frame pd dot data frame, and inside that a it's a key, the list of 1 comma 2 comma 3 comma 4 comma 5, another b 6 comma 7 comma 8 comma 9 10. So that's our data frame. So now let's randomly sample 3 rows from the data frame. Let's randomly sample 3 rows from the data frame. For that, let me take random sample of data frame is equal to df dot, let me use sample, and how many rows you want? 3 rows, and the state is a random state. Random state is equal to 42. That's what the random state I gave. And then let's print random df, and here is your data frame, sample data frame, and this is your actual data frame. Okay, I got your point. I got that you got my point, but still I want to do I want to use a real world data set. So I'll go for the players is equal to pd dot read csv. Let me go for the soccer players, and this is what my data is. 1587 rows. 1587 rows is my data points total. So now let me do the random sampling. So how many rows I want? I want around total 1587. I will go for the 800 rows. That's what my random sampling. So randomly sample this many rows. Randomly sample 8 9. Okay. randomly sample 898 rows. So random df random sample from players and players dot sample of, I want 898 rows, and random state I'll increase to 68 and much random. Then let me print the random players and players. Okay, invalid syntax, sample of, oh sorry, yeah, that's it. Let me bring it to, sorry, 898, and here is your 898 rows, and this is your total data. If you want to see the random players complete data, so let me give tail or head, whichever you want, and this is what. And if you want to see the shape of it, random players dot shape, sorry, shape is also attribute obviously, and 898 and the 6 columns, 898 rows, and that's what we said. I want 898 rows, and this is what is your data. So now let me say just simple random players, and this is overall data, and this is how we sample it, and this is random sample. So don't worry, we will be looking into the each sampling method in depth in our intuitive sampling for you course, but for now we'll have a high level understanding about the sampling. And these are not random sampling, stratified sampling. These are not only the sampling methods, we have lot more. We will be looking into the each sampling method in that course, in the specific course which is named as intuitive sampling for you course. And what next we have the stratified sampling. So in stratified sampling involves dividing the data set into different strata. So this is the overall data set. So this overall data set has been divided into different stratas: the blue color strata, red color strata, and green color strata. So or groups, you can call them as a stratum or groups based on the certain criteria, and then selecting samples from each stratum proportionally. So one from here, so this is 3, this is 3, and this is 6. So 1 from 3, 2 from 6, and 1 from 3. The proportionality should be maintained. You have 6 here, so that is the reason we have taken 2, and remaining 2 stratums are 1 each, so we have taken 1, 1. So this can be useful when the data set has distinct subgroups with different characteristics, and the goal is to ensure that each subgroup is represented in the sample. So let's take one example for this also. Simple example for data, I think stratified sampling. Then after the stratified sampling, we will move on to the next sampling method. Okay, let's work on the stratified sampling before we get into the other sampling method. So this one is stratified sampling. Let's take up I think players data. No, let's take up another data. I'll say this as cust is equal to pd dot read csv, and I'm gonna go with the customers shopping data and cust. Yep, here is your data. It's total 99,457 records, or 99,457 rows. Okay, now let's begin. So I want this to be converted based on the age group. So 3 or 4 stratas I want to do based on the age group. So I'll take this one. Let me convert this. So age groups. So first I need to make the respective age groups, and so this is my cust, and then age is the variable, and between 18 to 30, 45, 60. So I'm going to label it as 18 to 30, and total 4 labels. I'll say different labeling. So adult, mid-level, adults, mid-level, mid-aged, then you got that older and 60 plus. Okay, this is what the labels I want to give. So these are the 4 stratums I want to make out of this. So rest all remains same. So stratified sampling. So here for the stratified sampling I need to use a group by method that we have used during organizing data, and then age groups, and apply this function. Okay, so this sampling method, like sample frac 0.2. So select 20% of samples from each group. Of course you can have a proportion respectively, but still here I've taken uh, common, because adults, we don't know how many adults will be there, how many adults with this bracket. You don't know mid-aged how many will be, and older we don't know the frequency of each. So that's the reason we have applied the 20% common to each other. If you apply the 20% based on their size, the number of elements that we sample will also increase. So that's the reason I have gone for the sample 20% of. Okay, I'll go with the 30% samples from each group. Okay, let's execute, and let me call the stratified sample. And what's that? Okay, frac. That's it, no issue. So let me put that, and here is your data. So total 19,523 rows out of 99,457 rows, and 19,000, and the sampling you can see adults is your one sample, and 60 plus is another sample. Okay, and you can see the clear cut sampling. So if you want to give unique, that's okay. So that's what the stratified sampling for you. Then we have the systematic sampling. So systematic sampling, we will be looking into the systematic sampling now. So systematic sampling involves selecting data points at fixed intervals from the data set. For example, every nth data point can be selected. Here you see this on the screen. Every nth data point can be selected as a sample. So this can be useful when there is a pattern or a structure in the data, and selecting samples at regular intervals can capture that structure. And here is So here we have gone for every third data point. Every third data point we have selected to put into the sample. Let's take one example for the same. Third one is our systematic sampling. Same, I'll take the same data here. So nothing must be changed. No. Anyway, cust is ready. So data is ready. So now let me check. Define the sampling interval. I'll go with, let's define sampling interval. So n is equal to 3. 3 would be fine. N is equal to 3. Then, or I'll go for the 6. So now define, once the sampling interval was defined, now it's time to perform systematic sampling. So systematic sample is equal to cust dot ilog n and then I. So what it does is it selects every nth row from the original data. It selects every nth row from the original data. And systematic sample, and here is your data. So 16,577 and the overall data is 99,457, and this is what. And if you see, the systematic sampling is different, the data points you got is different, and the stratum or stratified sample is different, and this is how you get the stratified sampling, and this is how you get the systematic sampling. And this is the pictorial representation of random sampling, stratified sampling, and systematic sampling on the screen.